We're going to look now at that graphical interpretation that I have mentioned a few times. So let's have a look at these pictures. I'm going to just look at quadratics and linears for now. I know some of the equations we've looked at haven't been quadratic, but just to give us the idea of what's going on, let's just focus on quadratic and linear. So this first graph here, we've got a U-shaped quadratic and we've got a straight line linear. They are passing each other twice. There are two solutions or 2 points of intersection. When there are 2 points of intersection and you solve a quadratic and a linear, if the line passes through the curve twice, you will get 2 sets of solutions, just like we did in this question, 2 coordinates. So this then might look like -2 and 1, 4. Those will be the coordinates of the points of intersection. So in the second one here, we've got a quadratic and we've got a linear, but that straight line is actually a tangent to the curve. It's touching it in only 1 point, which means you're only going to get 1 solution. Now that looks like the first equation we saw. Now these equations are not matching those graphs, but it's just to give you an idea. So you might get coordinates of 2, 3 there. So 1 point of intersection. You also can have a situation with a quadratic that you've got a quadratic and a linear that don't touch at all. And in that case, there'll be no solution, no points of intersection. It's less likely that you're going to see that kind of situation in an exam, but it's good to be aware of it. So what we've got here is a question that looks very similar to what we've done before, but we've got a graph going with it or a picture of the situation with it. So let's see, we're just going to follow our steps as we did before. Equation 1, equation 2. Equation 2 looks like the easier one, the linear one. And look at that, y is already the subject. So we've 1 step out of the way already. So I'm going to sub this in to equation 1. So x squared plus y squared is equal to 25. But instead of y, I now know that y is equal to x plus 1. No, x minus 1. So I'm going to put x minus 1 instead of y. Don't forget to square it, and that's equal to 25. And now I'm just going to do stuff and see what happens. There's a bracket. I'm going to expand that bracket. I'm going to just take a little shortcut with expanding the bracket, which you don't need to do. I've squared the first one and multiplied the first by the second by 2 and squared the last. So that gives me 2x squared minus 2x minus 24 is equal to 0, bringing that 25 across to the left. I'm going to divide across by 2 because I can. You don't have to, but it'll make your life a little bit easier when it comes to factorizing. Minus 12 is equal to 0. We've got a quadratic, 3-term quadratic, so we should probably factorize it. That's nearly always the right thing to do. When you see this trinomial pop up, factorizing it is nearly always the right thing to do. So I've got x is equal to 4 and x is equal to minus 3. Now, let's see. I've got 2 situations happening here then. When x is equal to minus 4, how am I going to find, sorry, x is equal to positive 4, how can I find y? So I'm going to come back up to this equation here, where y is already the subject. So I know that y is equal to x minus 1. I'm going to sub 4 in for x. Y is equal to 3. So now I've got an x value and a y value, which gives me the coordinates 4, 3. Now let's look at the second situation. And in the second situation, we've got x is equal to minus 3. So when x is equal to minus 3, again, the same equation for y is equal to x minus 1. So y is equal to minus 3 minus 1. Y is equal to minus 4. So our coordinate here is x is minus 3, y is minus 4. Now let's see what that looks like in the picture. So what we had here, this first equation, x squared plus y squared is equal to 25, is actually a circle. Now you'll deal with that later on when we deal with that, when we come to circle geometry. And then you've got the line passing through it, y is equal to x minus 1. And these are the points of intersection. Now, if you look at these points of intersection, what we've got up here is 4, 3. And what we've got down here is minus 3, minus 4. Look at the solutions we got, 4, 3, and minus 3, minus 4. The solutions of the quadratic equations give us the points of intersection of the graphs. All right, so that's how the whole thing ties together. So I'd like you to have a go at this question here. In this case, we have got a U-shaped quadratic graph which is the first one, the y is equal to x squared. It's your basic, your kind of parent graph for quadratics. And then you've got a linear, y is equal to 2x plus 3. Y is already the subject, so this should be straightforward enough. So pause, have a go, and press play when you're ready to see me doing it. And right, an exam tip. We're back to this idea of method selection that I've mentioned before. If you see the words points of intersection, you go for simultaneous equations. Don't overthink it. It will almost always be the right move. So when you're going through your exams, there'll be lots of words and there might be graphs and pictures, and it can get a bit confusing. If you have this method selection sorted, where you see a phrase or a word and you link it with a technique, it's going to take so much of the confusion out of those words and their story, the stories that they put around the problems. So you see the words points of intersection, you go for simultaneous equations. You'll probably be right.